Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and incidentally as a theoretical economist and also as a systems and mechanical engineer. Today with this screencast, I'm continuing with the presentation of my paper, Theory of Microeconomics and Macroeconomics, Larsonian Econophysics. W. Larson was my theoretical physics mentor, and he was also my theoretical economics mentor. What I've done with both his physical science work and his economic science work is to make everything computational. So this is a computational version of the theory. If you want to just look at the logic behind all this, you could read Dewey's work, The Road to Permanent Prosperity. You can find it online. You can read it for free. And this paper is free. The link is given below. The reason for this is that we want to get the information out to as many people as possible. I do have a commercial software program called Optimal Economist, which puts everything, all the equations into effect. It's only $95 now. Originally, we were selling it for $295. We reduced it to $95 because of the recession/depression that we're currently in due to COVID-19. Okay, so this is part 5 screencast, the 5th screencast. We're in the macroeconomics section, and we're in the section National Income Accounting. So here we go. Please follow the paper and my voice as carefully as you can. The macroeconomics textbooks listed in the references all give the same standard identity equations for national income. And we actually agree with those incidentally. That's one of the few areas where we actually agree with conventional economics. Let NX sub 1 equal net exports minus imports. Then in nominal terms, rather than real terms, NX sub 1 equals X1, which is exports minus imports sub 1. That's in dollars. And therefore GDP sub 1 equals C sub 1 plus G sub 1 plus I sub 1 plus NX sub 1, where C sub 1 is the national consumption, G sub 1 is government spending, and I sub 1 equals the gross private national investment. C sub 1 is given below. I sub 1 is equal to I sub 0. That, by the way, I sub 1 is again, the gross private national investment. That would be in year 1. Equals the investment in year 0 minus C sub res 1 times GDP sub 0. And just as a reminder, C sub res 1 is the negative of the private sector investment rate. Okay, again, the negative of the private sector investment rate. So therefore, we can solve for government spending equals GDP sub 1 minus C sub 1 minus I sub 1 minus NX sub 1. National savings, and that would be private plus public, you know, like there would be any government savings, but, you know, whatever, it's negative, is S sub 1 equals I sub 1 plus NX sub 1 in dollars. And interestingly, the government deficit equals the trade deficit, the so-called twin deficit hypothesis. So this is quite important. This is a key thing here in this paper. We do accept the twin deficit hypothesis. So we do accept the national identity equations and the twin deficit hypothesis. The rest of most of modern economics we throw out. So deficit sub 1 equals NX sub 1, which is you know, the imports. So capital stock. The capital stock in year 1 must equal that in year 0 minus depreciation plus private investment. Okay, so K sub 1 equals 1 minus delta sub 1 times K sub 0 plus I sub 1. The true value of I sub 1 is U, so K sub 1 is also true. Okay, all right, now we come to the general equilibrium equations. If there are N sub P underscore R representative producer retailers in the country having a representative total cost of TC sub 1, and if there are N sub 1 representative workers that's worker consumers, really, in the country having an income of W sub 1, the wages, and B sub 1, that's again the investment income. Then for equilibrium, the nominal values are B sub 1 is equal to beta times GDP sub 1 divided by N sub 1. Makes sense. That's the share of the production going to the workers, which, by the way, is 70%. S sub 1 equals I sub 1 over N sub 1. That's the savings rate of the workers. And C sub 1, that's cost. So that's 1 minus tau sub W1 times W sub 1, plus 1 minus tau sub K1 times B sub 1, plus the transfers TR sub 1 minus whatever they're able to save. However, for the representative worker, T sub R1 should net out to 0 over the lifetime of the worker. So we get N sub P sub R times TC, that's total cost sub 1, equals N sub 1, which, remember, is the total number of workers, times W sub 1, the wages, plus B sub 1, the investment. Okay? Makes sense? And N sub P sub R times TR sub 1 minus X1 plus imports equals N sub 1 times C sub 1. Okay? Now consider the government. Tau sub K1 is the effective tax rate on capital. Tau sub W1 is the effective tax rate on labor, and I use those variables above. So now this is interesting. The question is, what do we use for the effective tax rates on labor and capital? We'll get to that in a moment. And total taxes and transfers are total taxes, that's TX R sub 1, equals tau K sub 1 times R sub 1 times K sub 1, that's the capital part, plus tau sub W1 times W sub 1 times N sub 1, that's the worker part. So we have, the two parts. We have the taxes on capital and the taxes on labor. And TX P sub 1 equals N sub 1 times transfers. Like I said, I'm not really too concerned about that. Transfers such as Social Security are supposed to net out to 0 in a pay-as-you-go system such as that in America. The Social Security payments, etc., by young workers are supposed to be exactly equal to the payments sent to retirees. So at least hypothetically, TX P sub 1 should be 0, and that's what we're going to assume in this paper. Therefore, the net consumption of the workers must be capital. So here we're using a capital. C sub 1 equals N sub 1 times the lowercase c sub 1, which is the consumption per worker. So as a check on the calculation of G sub 1, we have G sub 1 check equals TX R sub 1 minus TX P sub 1 plus the absolute value of the deficit. Okay, now we have to reflect these values back to the base year currency so that we can get a true comparison of what's going on. So GDP sub 1 true equals the ratio of CPI sub 0 to CPI sub 1. Again, 1 is the following year, 0 is the base year, times GDP sub 1, okay? So we correct GDP sub 1 back to the base year currency, which is in year 0. GR sub 1 true equals 100 times the quantity GDP sub 1 true minus GDP 0 divided by GDP 0. That's the true growth rate. I sub 1 true equals I sub 1. No ratio here because I sub 1 is the true value. NX sub 1 true equals NX 1. No ratio here because NX 1 is the true value, so no problem there. Capital S sub 1 true equals I sub 1 true plus NX sub 1 true. C sub 1 true equals C sub 1. No ratio here because C sub 1 is the true value. G sub 1 true, that's the government spending again. CPI sub 1 divided by CPI sub 0 times G sub 1. Makes sense. K sub 1 true equals K sub 1, no ratio there. B sub 1 true equals B sub 1 times CPI 0 divided by CPI 1. Again, that's the true investment rate earned by the worker. C sub 1 true equals C sub 1, so no ratio there. That's the consumption per worker. S sub 1 true is S1. And S1 is the true values of the savings, and then any transfers. Like I said, should be 0 for the representative worker consumer. These values would then be used as the next set of base year values to use for the succeeding year. So you can keep going with this and do a projection. Okay, fortunately MathCAD has functional forms, so we can put all the previous equations into a function called Macroecon. All the above equations can put in MathCAD functional form for ease of computation, and it's really on the other side. We'll take a look at that later. You can't really see the expression. So now let's go look at some worked examples for a number of years. We go back to 2006. So 2005 would be the base year 0, and 2006 will be year 1 for this example. The data are known, so no extrapolations need be done. So you can read through all these values here. I'm not going to actually, just take a moment, take a look at what I have here. For example, N1 is 144.4 million workers in America on average for 2005. We've got the wage rate, the rate of change of wages from year 0 to year 1. And then we get all these results, which is pretty amazing. Again, I'm not going to read all these off to you. You can study this when you download the paper. So, what's funny to me is that some economics textbooks and economics books in general don't give actual examples. I mean, just look at all the example calculations I give you here. And then I do some ratio analysis. So, for example, G sub 1 true divided by GDP sub 1 true. So that's the ratio of government spending to the gross domestic product, and that's, you can see they're 0.185116 or 18.5%. And interestingly, the effective tax rates, I set the effective tax rates to be the same for labor and capital. It's just another one of those assumptions to make things a little bit easier. So it's about 12.8%. That's the actual true tax rate, with all the deductions and everything else. So let's summarize what the representative American worker consumer in 2006 had. A wage, $62,104.02. That's, obviously wages plus fringe benefits and like vacations. Investment income, $26,958.86. Total income would be $89,862.88. Taxes, $11,585.18. Disposable income, $78,277.70 there. Consumption, $62,831.72. And savings, S1 equals $15,445.98. I'm going to close this off. All right. So, and that includes Social Security, obviously. Please note that these results are per worker, not per capita. Per worker. So just keep that in mind, not per capita. Also note that these results are mean values, not median values. Average depreciation rate is set to 0.066 per year, 6.6% per year, and assuming straight line depreciation over 15 years. It's just a basic average. And then we have the next one, work example 2 for 2007. Again, take a look at the paper, and you can see all this stuff here. So let's describe the representative American worker consumer 2007. So in 2007, W sub 1 is 63,147.05. B sub 1 equals 27,234.45. Total income 90,181.51. Taxes 12,297.26. Disposable income 78,184.25. Consumption 63,184.25, and savings 14,700. So again, these results are per worker, not per capita. I mean, if it were done per capita, these numbers would be very substantially reduced. Okay. Then I have the next works examples for 2008. Scroll down. For 2008, we have W sub 1 equals 64,089. B sub 1 equals 27,466.71. Total income 91,155.71. Taxes 13,919.60. Disposable income 77,636.11. Consumption 63,953.85. And savings 13,682.26. I said previously that would include Social Security. That's not really correct because we're zeroing out the transfer, so I have to retract that statement. Again, these results are per worker, not per capita. And you might be thinking, well, these numbers seem pretty high. You don't usually know that many people with a total income of 91,555. But there are some people who are earning a great deal more, and that kind of skews the results a little bit. Go to 2009. Here we have W sub 1 equals 64,983.42. B sub 1 equals 27,850.04. Total income 92,833.45. Taxes 15,789.85. Disposable income 77,043.60. Consumption 66,124, and savings estimate was 10,119.23. So that's like a savings rate of 14%. I know when I was working full time as a computer consultant as well as a software developer, I tried to save about 50% of my gross income through the company. Okay, in 2010, all these numbers, you can download the paper and check these numbers yourselves. And so, wage or salary income 65,738.10. Investment income 28,117.47. Total income 18,911.57. Taxes 8,165.42. Total income 78,746.15. Consumption 66,665.92, and savings 12,080.23. So the savings rate is 15.34%. And okay, now I have some notes on these. These are some basic conclusions from the runs I just did here. So to test theoretical equations, known values of n sub 1, that's the number of employees, I sub 1, that's investment amount, x sub 1, that's exports, imp is imports, inflation, G1, and GDP observed have been used to calculate A sub vol 1, C sub res 1, delta x, delta import, Y sub vol 1, and V sub 1 respectively. Alternatively, if Y sub vol 1 is known as assuming that change in service capacity utilization equals that of change in industry capacity utilization, then the effective G sub 1 for the year could be calculated. The data are given as chain $2,005 rather than reflected back to 2005 as in our calculations, although the differences are slight. 3. Ups and downs in private sector savings and investment, personal plus business, are the cause of recessions and booms. For the years calculated, the personal savings rate as a percent of disposable income has varied from about 13% to about 22%. C sub res 1, which is the negative of the change in the private sector investment rate, relative to GDP 0, has varied between 0.01 and minus 0.01. The true effective interest rate, return on capital, average rental rates, etc., varies from about 11% to 14%. So that's the true value of capital, not the fictitious treasury rates from the government. The true effective interest rate paid out to real capitalists is somewhere between 11 to 14%. The effective tax rate on capital and labor have been set equal. This is purely an assumption, as there is apparently no data on this issue. However, many economists believe that this is the correct policy, whether or not it's true in practice. The government always seems to spend 4 to 5 percentage points more than it takes in. Average disposable income has ranged from about $77,000 to about $83,000. Let's see, we're at 20 minutes, so we've got 10 minutes yet. Okay, now we can do extrapolation to other years in 2005 dollars. So there are lots of different ways to do an extrapolation. I give a lot of methods here. You can choose whatever you want. MathCAD's predict function can be used to do simple extrapolations of macroeconomic variables such as GDP or investment I or government spending G. As in the microeconomics section of this paper, it's convenient to put the past data into a spreadsheet and then import the data in. So I did this in Excel, and of course, you get the Excel program if you get the commercial software program Optimal Economist, which, as I said, is only available for $95 from TransPower Corporation or Amazon.com. Everything else here, the paper is free. Dewey B. Larson's work, The Road to Permanent Prosperity, that's free to read online, but I do charge for the commercial software program if you want that. But we did drastically reduce the price from $295 down to $95, so it's quite a bargain. Anyway, you also get the spreadsheets with it. Okay, so now I just get all these submatrix values to use in what follows. It's a lot of them. So not all the vectors defined below will be used in what follows, but they have all been listed for convenience. Okay. So the very simplest extrapolation is to use GDP sub 1 observed. And I noticed that I have to double the value because that's what MathCAD requires. It would get confused if I used just GDP sub 1 observed. We'll extrapolate 10 years from 2010, so it brings it up to 2020. But of course, this does not include any shocks to the system, such as the COVID virus, so keep that in mind. To handle shocks to the system, you would simply drastically reduce the number of employees, basically. So if 40% of the workers are out of work, then that would automatically decrease the GDP by 40%. So anyway, we'll extrapolate 10 years from 2010 using 24 past values. The values for 2009 and 2015 can be compared. Okay, so really it's going from, let's see. Yeah, okay, so the values for 2011 to 2015 can be compared with that observed. So if you look at the 2020 values in here, it's going to be more effective of, what it would have been without the virus. So remember, I wrote this paper around 2015. Okay, the remaining years of production. So here we go. So you can see this is the prediction number 1. It's actually going down a bit, which is interesting. So it's a bit of a surprise. I guess as the GDP in 2005 dollars will be slightly lower over the years 2010 to 2020. So perhaps a better approach is to use G sub 1 and V sub 1. And we use this expression here, that is, we use MathCAD's vectorized function. So here's the prediction 2. And that's not really too much different. Remember, we're doing all this in 2005 dollars. So also decline. So now let's try linear regression. So here's the, you can see how to put this into a linear regression format. And this one, let's see. This one actually goes up. We get the y-intercept and the slope. It's much more optimistic. Now let's try using the GDP growth rate. The mean value of the GDP growth rate is GR underscore mean. So it's the mean value of GGR1 observed, and that comes up to being 2.629%. With this value, we can make another set of predictions. And so that gives you the 4th one. So a little bit less optimistic than the last one. And now we can do a complex extrapolation. Obviously, the 4 simple extrapolation is not work very well because by inspection one can see that there should usually be a steady small growth in GDP. Of course, unless there's some exogenous factor like a virus. What we'll do now is extrapolate the parameters of the theory and then use those to extrapolate the GDP. So recall that GDP sub 1 equals GDP sub 0 times these factors. 1 plus C res 1, A sub vol 1, times 1 plus F sub W1, times 1 plus delta X. Where A sub vol 1 is just the ratio of N sub 1 to N sub 0. Okay, so using MathCAD's vectorized function, we can obtain each term in parentheses from the vectors imported from the spreadsheet and then obtain the mean values for the series, including the inflation. Okay, so the mean factors that we have is 1.019587. So here we go. So we get predict 5, which is the green one, the green solid, right? Yep. So the theory implies that the minimal growth that we can achieve is about 2%, and that's what most economists agree to. It's about 2%. But if the money supply is increasing at 2%, well, then the prices should not be changing. Check that. Everything you think. Okay. So one last method is to use the individual factors rather than the mean values. So again, we use the MathCAD vectorized function, and this is 6 dotted. The sixth prediction lies between the linear regression and the mean factors prediction, and it crosses the prediction based on the mean growth rate. But the fifth prediction is probably still the most accurate. So reference 39 shows that the real growth rates for the U.S. economy for 2011 and 2015 are 1.6, 2.2%, 1.7%, 2.4% respectively. The mean value is 2.06%. This compares with the mean value for the factors calculated by prediction 5, which is 1.96%. So the theory is verified within the observation error if we're using prediction 5. And prediction 5 is the factor's mean, which kind of makes sense. Okay. So similar calculations can be done for the prediction of government expenditures, investment rates, taxes, and the other variables. But that's left to the database program, which is Optimum Economist. So I'm going to stop here. We'll do the recommendations next time. Again, please study the paper. It's free. It's a free PDF. Please leave your comments below. Please sign up, subscribe to my channel. I give the most amazing content. You won't find this content anywhere else. We have the true theory of the universe in our physical science, and we have the true economics theory in our economic science screencasts. So again, study the theories, and thanks for your attention.